This is November 2022. Paper is 52. Eggshells contain a high percentage by mass of calcium carbonate. Calcium carbonate, a student wants to find out what percentage of an eggshell is calcium carbonate and uses the following method. This method uses a known excess of acid to dissolve the eggshell. The amount of unreacted acid is then determined by titration with an alkali. Assume the acid only reacts with the calcium carbonate in the eggshell. Wash an empty eggshell with distilled water. Warm the eggshell in an oven for a few minutes until dry. Grind the eggshell into a powder. Weigh approximately 2 grams of the eggshell powder into a conical flask using a balance which measures to 3 dp. Add 100 cm cube of 2 mole per dm cube hydrochloric acid to the conical flask. Acha, he's getting hydrochloric acid. Loosely cover the conical flask and leave for 2 days. Filter the contents of the conical flask with any rinsings into a 250 cm cube volumetric flask and top up to the mark using distilled water. Transfer 25 cm cube of the solution prepared in step 7 into a conical flask. Add a few drops of thymol blue indicator and titrate against 1 mole per dm cube sodium hydroxide using a 50 cm cube burette. The calcium carbonate in the eggshell reacts with the excess hydrochloric acid as follows. The excess acid reacts with the sodium hydroxide solution as follows. Okay. How the student could confirm the eggshell is completely dry in step number 2. He can leave it for some time in air or something like that. One simple idea can be like this.
You can also leave it to dry and then reweigh it until it's a constant mass.
Okay, this is a possible approach. So we can weigh the eggshell. State why the eggshell is made into a powder in step number 3 before making up the solution. Do you think powdering will increase the surface area, which increases the rate of reaction?
Yes.
Suggest why the solution is left for 2 days in step 6 before being used. Do you think it's a slow reaction? Because when you're giving so much time, it means the activation energy of the reaction is very high, and reaction will take a good amount of time to complete.
Mm.
It looks to be the same. 2 days. It seems that reaction is slow. The student uses exactly 2.136 gram of powdered eggshell and obtains the results shown in the table. Rough reading and then 1, 2, 3. First answer is after subtraction,
It will be 16.3.
and 16 point. Acha, second one, the first one. Okay. And the second one,
16.
okay. The third one,
16.2.
so what we should take, calculate the mean title.
We should take the second and the fourth.
Second and the fourth, you mean 16.30 and 16.20.
Yeah.
Okay, now take the average.
It will be 16.25.
Calculate the amount in mole of unreacted HCl in the solution prepared in step 7. Show your working amount of in mole of unreacted HCl. Amount of unreacted HCl is the second part. So the reaction is 1:2. So should we find the number of moles of calcium carbonate? So what is the number of mole? What is the number of mole of calcium? What's the molar mass of calcium carbonate?
1 second.
Or should we make a comparison with NOH? Acha, unreacted. Oh, actually, this is the reacted one. So we need a correction. if we are dealing with unreacted HCl, so what is the concentration of NaOH?
1 mole per decimeter cube.
And using a 50 cm cube. But how we get the volume of NaOH used? Is it this tighter value? 16
Yeah,
cm cube. So we
yeah.
just use is equal to CV. (16.5). So find the number of moles.
It will be 0.01625.
625. Why?
Yeah, it's 16.25.
Oh, the average is not 16.5.
No, no.
Say, got it. So this is the mole, and what the equation says, what is the mole ratio with NaOH? 1:1.
Mm.
Okay. So this is then the same number of moles are coming for HCl.
Yes.
Then calculate the amount in mole of calcium carbonate that react with the excess of acid. So part number 3, should we find the molar mass of CaCO3 first?
Yes.
And we find the amount of HCl. How we manage HCl here? Because HCl is the first put HCl in CaCO3, and the remaining excess HCl is reacted by NaOH. So HCl is totally gone. But how much HCl, how much is the concentration of HCl introduced? 100 cm cube of 2 mole per dm cube HCl. Okay. Okay. Volume of 100 cm cube. What is the concentration of acid? It is 2 mole per dm. So first we find the total number of moles of HCl getting into the system. How much is this?
0.2.
And we know now that how many moles used here, unreacted moles are 0.01625. Now, so the moles which have reacted with calcium carbonate is 0.20 minus 0.01625. So subtract them.
It will be 0.18375.
0.18.
375.
Okay. So after subtraction, I'm getting 0.18375. Then apply the ratio. Calcium carbonate HCl is 1:2. So the moles of calcium carbonate will be half of it.
Mm.
0.18375. 0.18375 upon 2. So half it.
It will be 0.09 1875.
Okay, how much is the mass or molar mass for
It's
calcium
100.
is 40.1, carbon is 12 plus 16 into 3. Yes, 100 point.
1.
Okay. So then we find the mass. No, actually we need the amount in moles. Okay, fine. So actually, if we found the mole, then why we find the molar mass then?
To find the mass.
But he's asking for the amount in moles.
Oh,
You're right. In the mass is equal to number of mole into MR.
it will be 9.2 grams.
What is the mass of the sample? It was How much
2 gram.
2 gram.
Yeah.
Huh? 2 gram? Then how we got 9.2? Something is wrong. In a sample of 2 gram, how we got something is wrong. Somewhere we made the mistake. Because our answer is coming more than 2, which is not possible.
Mm.
We have to check all the values. It was 0.01625.
Yes.
Hence, thing is wrong. Because it's not something is wrong. Transfer 25 cm cushion prepared in step 7 into a conical flask. Add a few drops of thymol blue indicator in 1 mole per dm cube HCl using a 50 cm cube burette. So NOH is 1 is NOH HCl is 1:1, right? Seven and eight. Something is wrong in 7 and 8 steps. Filter the contents of the conical flask with any rinsings into a 250 cm cube volumetric flask, and from 250 we have taken 25. So here is the mistake. Actually, our moles we got here. Okay, our moles we got, the NOH moles we got here are 0.1625. And this is the concentration of NOH and the so this is the mistake. Actually, we got the moles in 0.01625. This is the number of mole in actually 20 to 50 to 25 cm cube. So in 250, how much they will be? This is the mistake. This is in 25 cm cube. This is the sample reactant. Our HCl was originally 250 cm cube. So we have to find the moles in 250 now.
Mm. Okay.
This is the mistake. Now, this is the working. We overlooked actually dilution.
So it will be 0.1625.
Now you have to do the subtraction again.
It will be 0.0375.
Okay. So divided by 0.37. Okay, now divided by 2.
It's 0.01875.
Okay, now we got it and we have the mole here, 0.01875. Now, so see the calculation.
So it's 93.8%.
93.
0.8.
That is fine. Name a suitable piece of apparatus which could be used to transfer 25 cm cube of solution. So should we mention pipette?
Yeah.
In step 4, a conical flask is weighed using a balance accurate to 3 dp and the mass recorded. The eggshell is placed in the conical flask and the mass increased by 2.136. So he's asking to calculate the percentage error. Three DP. And then the upper or lower bound is
Divide by
now look this. We found the upper lower bound, and then we will take the two readings.
so we multiply by 2.
We have to multiply by 2. And what is the value? We have 2.136.
Mm. 0.0468.
So this paper is continued. So we stop here and we will inshallah complete it in our next class.
Inshallah. Thank you.